Proper use of an amp meter procedure for maintenance discussion requires specific materials. Firstly, an amp meter. Secondly, insulative gloves. Thirdly, safety glasses. Fourthly, electrical test probes. Safety precautions are paramount. Ensure the circuit is de-energized before performing any measurements. Wear insulated gloves and safety glasses. Never touch live wires or components with bare hands. For the procedure, the first step involves setup and preparation. Select the appropriate amp meter range for the expected current flow. Connect the red probe to the positive, red terminal and the black probe to the negative, black terminal of the amp meter. If using clamp-on ammeters, ensure proper probe orientation, clamping the probe onto the current-carrying conductor. The second step is current measurement. Place the test probes or clamp the conductor in the circuit where the current is to be measured. Hold the amp meter steady and observe the reading on the display. Note the units of measurement, such as amps, milliamps, and so forth. The third step addresses troubleshooting. If the amp meter reading is 0, check for loose connections or a blown fuse. If the reading is higher or lower than expected, verify the accuracy of the amp meter and the correct connection points. If the amp meter overload occurs, disconnect the probes immediately and adjust the range. The fourth step involves multiple measurements. To measure current in different conductors or circuits, repeat the procedure for each location. Disconnect the probes from the previous measurement point before connecting to the next. The fifth step involves the interpretation of results. Compare the measured current values to the expected values or reference ranges. Deviations from expected readings may indicate electrical problems or faulty components. The sixth step concerns documentation. Record the measured current values, circuit location, date, and any observations. Maintain a log of all measurements for future reference. Additional considerations include the use of a true root mean square (RMS) multimeter for accurate measurements of alternating current (AC). Ensure the amp meter is calibrated regularly. Be aware of the limitations of the amp meter and its maximum current rating. Always follow all applicable electrical safety regulations and best practices. To elaborate further on selecting the appropriate range, understanding the expected current flow is crucial. If you're unsure of the current's magnitude, start with the highest range on the amp meter and gradually decrease it until you get a meaningful reading. This prevents overloading the meter, which can damage it or give inaccurate results. When connecting the probes, ensure they are securely attached to the terminals. Loose connections can lead to inaccurate readings or even arcing, posing a safety hazard. For clamp-on ammeters, proper orientation is key because these meters use the principle of electromagnetic induction to measure current without directly contacting the conductor. The clamp must fully encircle a single conductor to get an accurate reading. If it's not properly oriented or if it's clamped around multiple conductors, the readings will be invalid. During current measurement, it's important to hold the amp meter steady. Any movement can cause fluctuations in the reading, making it difficult to obtain an accurate measurement. Also, be mindful of the units displayed on the meter. Amps are the standard unit, but smaller currents may be displayed in milliamps, where 1 amp equals 1000 milliamps. Understanding these units is essential for proper interpretation of the results. When troubleshooting, a 0 reading could indicate several issues besides loose connections or a blown fuse. It could also mean that the circuit is not energized, or that the component being tested has failed completely. Always double-check the power source and the circuit's integrity before assuming the meter is faulty. If the reading is higher or lower than expected, consider the possibility of other loads in the circuit that were not accounted for. For instance, a seemingly simple circuit might have hidden parallel paths that contribute to the overall current flow. Additionally, environmental factors like temperature can affect the resistance of components, leading to variations in current. If the amp meter overloads, it's a sign that the current is exceeding the meter's capacity. Continuing to expose the meter to such high currents can cause permanent damage. Disconnect the probes immediately and select a higher range if available, or use a different meter with a higher rating. When taking multiple measurements, it's good practice to label each measurement point clearly. This helps avoid confusion later on when analyzing the data. Also, make sure to disconnect the probes from the previous measurement point before moving to the next. This prevents accidental shorts or unintended current paths. Interpreting the results requires a good understanding of the circuit's design and the expected behavior of its components. Deviations from expected readings can point to a variety of problems such as short circuits, open circuits, component failures, or insulation breakdown. Comparing the measured current values to the manufacturer's specifications or to historical data can help pinpoint the source of the issue. Accurate and thorough documentation is crucial for effective maintenance and troubleshooting. Record not only the current values, circuit location and date, but also any relevant observations about the circuit's condition or behavior. This information can be invaluable for future reference, especially when diagnosing intermittent problems. Using a true RMS multimeter for AC measurements is particularly important because many AC circuits have non-sinusoidal waveforms. Standard multimeters that are not true RMS only provide accurate readings for pure sine waves. True RMS meters, on the other hand, accurately measure the effective voltage or current of any waveform, regardless of its shape. Regular calibration of the ammeter is essential to ensure its accuracy. Calibration involves comparing the meter's readings to a known standard and adjusting it if necessary. The frequency of calibration depends on the meter's usage and the manufacturer's recommendations. Be aware of the limitations of the ammeter, including its maximum current rating, its accuracy, and its operating temperature range. Exceeding these limits can damage the meter or lead to inaccurate readings. Always consult the meter's manual for detailed specifications. Finally, always follow all applicable electrical safety regulations and best practices. This includes wearing appropriate personal protective equipment, such as insulated gloves and safety glasses, and following lockout/tagout procedures to de-energize circuits before working on them. Electrical safety should always be the top priority when working with electrical equipment. Furthermore, let's discuss the importance of understanding circuit diagrams and schematics. Before taking any measurements, familiarize yourself with the circuit's layout and the function of each component. This will help you identify the appropriate measurement points and interpret the results more effectively. Also, consider the impact of the ammeter itself on the circuit being measured. Inserting an ammeter into a circuit has a small amount of resistance, which can affect the current flow. In most cases, this effect is negligible, but in low voltage, high current circuits, it can be significant. If necessary, compensate for the meter's internal resistance when interpreting the results. In addition to measuring current, ammeters can also be used to check for continuity. By setting the meter to the continuity setting, you can quickly determine whether a circuit path is open or closed. This is a useful technique for troubleshooting wiring problems and identifying broken connections. When using clamp on ammeters, be sure to position the clamp correctly around the conductor. The clamp should be perpendicular to the conductor, and the conductor should be centered within the clamp. Any misalignment can affect the accuracy of the reading. Also, be aware of the presence of nearby magnetic fields, which can interfere with the meter's readings. Keep the meter away from transformers, motors, and other sources of electromagnetic interference. When interpreting the results, consider the possibility of harmonic currents. Harmonic currents are caused by nonlinear loads such as electronic devices and fluorescent lighting. These currents can distort the AC waveform and lead to inaccurate readings on standard ammeters. True RMS meters are better equipped to measure harmonic currents accurately. Another important consideration is the temperature coefficient of the ammeter. The temperature coefficient specifies how much the meter's accuracy changes with temperature. If you are working in extreme temperatures, be sure to account for the temperature coefficient when interpreting the results. Also, be aware of the effects of humidity on the ammeter. High humidity can cause condensation inside the meter, which can damage its internal components. Store the meter in a dry place when not in use. When troubleshooting electrical problems, it's often helpful to use a combination of measurements, including voltage, current, and resistance. By analyzing these measurements together, you can gain a more complete understanding of the circuit's behavior and identify the root cause of the problem. Finally, remember that electrical safety is paramount. Always follow safe work practices and use appropriate personal protective equipment when working with electrical equipment. If you're not comfortable working with electricity, seek the help of a qualified electrician. In summary, proper use of an amp meter involves careful preparation, accurate measurement techniques, thorough interpretation of results, and strict adherence to safety regulations. By following these guidelines, you can ensure accurate readings and safe working conditions. Remember to always consult the amp meter's manual for detailed instructions and specifications. Regular training and practice are essential for developing proficiency in using amp meters. Encourage maintenance personnel to participate in hands-on training sessions and to review the proper procedures regularly. This will help them stay up to date on the latest techniques and safety practices. Furthermore, consider the use of simulation software to provide maintenance personnel with a safe and controlled environment to practice using amp meters. Simulation software can replicate various electrical circuits and scenarios, allowing trainees to experiment with different measurement techniques and troubleshooting strategies without the risk of electrical shock. Also, emphasize the importance of teamwork and communication. Encourage maintenance personnel to work together and to share their knowledge and experiences. This will help them learn from each other and to develop a more comprehensive understanding of electrical systems. When documenting measurements, use a standardized format to ensure consistency and accuracy. Include the date, time, circuit location, measured values, and any relevant observations. This will make it easier to analyze the data and to identify trends over time. Additionally, consider the use of electronic data logging systems to automatically record and store measurements. Data logging systems can save time and reduce the risk of errors. They can also provide valuable insights into the performance of electrical systems. When interpreting the results, be aware of the limitations of the amp meter and the potential sources of error. Consider the accuracy of the meter, the effects of temperature and humidity, and the presence of harmonic currents. Also, be aware of the potential for human error, such as misreading the meter or misinterpreting the results. To minimize the risk of error, always double-check your measurements and consult with other experienced personnel. Finally, remember that continuous improvement is essential. Regularly review the amp meter procedures and identify areas for improvement. Encourage maintenance personnel to provide feedback and to suggest ways to enhance the training program. By continuously improving the training program, you can ensure that maintenance personnel are equipped with the knowledge and skills they need to safely and effectively use amp meters. Furthermore, it's important to periodically evaluate the effectiveness of the training program. This can be done through written tests, practical assessments, and on-the-job observations. The results of the evaluation can be used to identify areas where the training program needs to be strengthened. When selecting amp meters, consider the specific needs of the maintenance department. Choose meters that are durable, reliable, and easy to use. Also, consider the range of currents that need to be measured and the accuracy required. Invest in high-quality meters that will provide accurate and reliable measurements for many years. In addition to amp meters, provide maintenance personnel with other essential tools and equipment such as voltage testers, insulation testers, and ground resistance testers. These tools can help them diagnose a wide range of electrical problems and ensure the safety of electrical systems. Finally, emphasize the importance of ethical conduct. Encourage maintenance personnel to be honest and transparent in their work. They should never falsify measurements or cover up problems. Ethical conduct is essential for maintaining the integrity of the maintenance department and ensuring the safety of electrical systems. By following these additional guidelines, you can create a comprehensive and effective amp meter training program for your maintenance personnel. This will help them safely and effectively use amp meters to troubleshoot electrical problems and maintain the reliability of electrical systems. Remember to always prioritize safety and to continuously improve the training program.